Hi there. My name's Dave Stokes. I'm a community manager for MySQL products, and I'm talking today at DataCon LA about MySQL indexes, histograms, and other ways to speed up your queries. I have 40 minutes or so, and this is normally anywhere from a 1 hour to 3 hour talk. I won't get through everything, but I'll get through the heart of the presentation. And by the way, the slides will be available for download. I'll show you that a couple times. By the way, if I talk about something that's not already a product, like during Q&A or I go off on some tangent, basically you can't hold it against me because I have the safe harbor agreement that says I don't know about future products. I know some of them, don't know all of them, don't know all the details of all of them. So take anything I say about a future product with a grain of salt. By the way, if you're running MySQL 5.6, it reached end of life status in February of this year. So please upgrade to 5.7 or better yet, 8.0. Oh, by the way, if you want to try test drive the MySQL database service for free, you can get $300 in credits by going to oracle.com/cloud/free. $300 on the lower end configurations will run you for a while. If you want to try out our high availability system where you run NODB cluster, or you want to try HeatWave, our new analytics engine, which also has a machine language component that will help tune your queries. You can also do that on here. Thank you for putting up with my ad for work. That pay me to do this sort of thing. Okay, what is this session about? Well, basically, nobody complains when the database is too fast. And if you start seeing things slowing down, you start speeding up queries, and you start looking for help online, it's like reading a bad Harry Potter fan novel. It's not dark art, it's engineering. And understanding how to speed up things is treated like magic, but it really isn't. It's fairly simple stuff. The trick is the optimizer, and we'll get into that in a little bit. So today we're going to be looking at the proper uses of indexes and histograms, and that's quite a subject in itself. By the way, this is a dry subject. If you are a junior DBA or a junior developer working in a database, you may not pick this up the first time you look at it. You might have to play with it a little bit. Download the slides, links down below. Look for LA DataCon, MySQL indexes, and histograms, and refer to it. Try some of it out. Come back a couple days later, try it again. You won't be able to pick it all at once, so don't try to absorb it all at once. And by the way, when you're working on queries to improve performance, work on the query that runs the most frequently. Something that only runs once a year. If you take it from 2 hours and 15 minutes down to 2 hours and 12 minutes, is not going to impress anybody. But if you have something that takes half a second and you get down to a tenth of a second, and it runs 10,000 times an hour, that's a big savings. And by the way, your optimizations will change over time. Need to warn you about that. Got to warn you today, there's no agenda on system configuration, either the operating system or the MySQL server. I'm not talking about hardware or networking settings or cloud settings or setting up replication or anything like that. Those are all major subjects, and I only have 40 minutes, so we have trouble getting through them too. Also, not covering how to normalize your data. Recommend that you do at least third normal form or better. I also recommend now using JSON stub tables to get rid of needless many-to-many joins. Sometimes you have to go to one table, look up another table, look up another table, look to another table. That's very expensive. Put a JSON column in that first table and avoid those other lookups. Also, you have to think about how you're going to use your data. The way you set up your data derives how it can be accessed. As I say here, you don't use a fork to eat soup, and you really have to know how you're going to consume your data at the far end. And by the way, if you don't normalize your data, it will really hurt your performance. I've been doing databases for over 30 years now, and no matter how much training you give a dachshund, it's not going to run a thoroughbred horse over a mile racetrack. If you have a badly designed system, it's inherent in the system and it won't get better. Okay, the big thing we have to consider today is the optimizer. The optimizer is what sees your query after it's been syntax checked, and then it says, okay, how do I pull all this stuff together and give them the information they want in the least costly way? There's a whole bunch of mathematical models and heuristics built into that. And some of them don't work for everybody. Some have assumptions that you'll see later that are kind of weird. And what basically happens is the optimizer looks at the statistics to figure out how to get the data, or how it got the data in the past, and produces a blueprint or a query plan on how to get that for you. Now, the optimizer wants to get your data the cheapest way. Well, what do you mean by cheap? The least expensive number of disk reads. And in the early 70s, when this was all being formulated, relational model and all that, disk reads were very, very slow. The devices were terribly slow, very expensive, and you wanted the least amount of redundancy in your data, which helps with the relational model. So reading from memory is 100,000 times faster than reading from disk. So if you can save disk reads, all this other stuff, that's all built in the model. Now the optimizer has all this information, and it's based on historical statistics, stuff it's gathered in the past as it goes out to find this data. Now, like a GPS, the information might be bad. Like if I wanted to go to lunch, I can turn left or right out of the driveway, and that determines where I go. What I don't know is that my neighbor three houses to the left has blocked the road with a traffic accident. Down to the right, there's a train over the tracks. And I also don't know that the restaurant is either closed today or relocated. So historical information is great a lot of the times, but it's not always great. And what we want to do is get the best information to the optimizer. Now, the optimizer, when it goes through all the options, will produce something called a query plan. I'll show you how to get one of those in a minute. And by the way, MySQL wants to optimize a query each time it sees it. Other databases like Oracle, you can actually lock down the query. MySQL wants to re-optimize it every time. Now, there are some other ways to get around that that are later in the slide deck. I'm not going to be able to cover it today. So, if you have 5 joins, that means 5 different tables that can be put together 5 different ways. That's 5 factorial or 120 different options. Writing an optimizer is a major undertaking. The way you see what the optimizer is thinking is using explain. And explaining explain requires a great deal of explanation, and I can't get into all of it today. I'll kind of give you an introduction. The MySQL manual and some of the books I'll mention later will greatly help you here. Now, explain is real simple. The basic idea is that you prepend the word explain, hopefully you can follow my mouse here, in front of a select, delete, insert, replace, or update statement, and it will show you what's going on. Of course, to make this even more interesting for you, there's various types of explain. There's different formats. There's explain, analyze, visual explain, and you'll see a glimpse of those in just a moment. Okay, here's an example. We have a query. Select star from city where country code equals GBR. So that's select wildcard, everything from the city, and we're running through the records where the country code is equal to GBR. We prepend explain to that. So there's our query. Here's the output from explain. I won't go into that in much detail today. And down here is the query plan. Notice it's taking the wildcard, the asterisk up here, and put in all the column names because it has to go out and grab those. It just can't go like throw a lasso over the entire herd and pull in everything. It has to distinctly name all those. That is the query plan. That's what the server will actually run when it comes time to run your query. Now, if you have MySQL Workbench, you can run visual explain and it will give you some information. It tells you that on the city table, you're going to be doing a non-unique key lookup on country code. You're going to need to read 81 rows, and the total cost of the query is 73. We'll round up to 73.73 there. Now, if you use explain format equals tree, this is a different query, just slightly. We're selecting all from city again, but we're pulling in some information from another table. It will tell us what type of join is made here. In this case, it's an inner hash join, and the columns that are being joined, and the cost and the number of rows are going to have to be read. Now, for those who want even more information, this will be more important to you as you progress through the type of stuff we're going through today. You're going to get a lot more information. Total query cost, the number of rows examined, where the various costs are associated, and more information about the columns used. So there's more and more information the more you dig down. Now, something we added in 8.0.18 a year ago was explain analyze. All the other explains you've seen so far run on historical information. Explain analyze actually runs the query and gives you the actual time and the actual number of rows. This is great. By the way, if you see skew, run analyze table on your tables, make sure the statistics are built up. And by the way, if you have a real nasty query, you put explain analyze on there, it will do what the query normally does, and it might lock up things that you don't want locked. And by the way, once again, this is real numbers, not off the estimates. We'll go back to explain in just a little bit, but first a word on indexes. Well, what is an index? Well, according to Wikipedia, a database index is a data structure that improves the speed of data retrieval. Yeah, good answer. If I was a college professor, I'd give that a good A, maybe an A minus. I like to think of an index as a table or shortcuts to another table. It's some of your data is in a small table that points to the real table. By the way, indexes do take up memory. And of course, to make this even better for you, is we have many types of indexes. Here's the syntax for create index. You can see we have create unique, full text, spatial, a whole bunch of options for blocking and putting in comments and using B trees or hashes. Now, MySQL uses something called a clustered index. What that means is the index itself is stored with the data in the sequence of that index, and that is called a key. Since it's the main one, we call it the primary key. MySQL basically has primary keys and everything else is a secondary key. Now, for best performance, choose the primary key columns carefully for the most performance critical queries. Going back and modifying this is a pain in the butt. Now here's my little mental model. This is the actual to size or the way it actually works, but this is a nice little mental model. I want to look up record 3 in my little index, and it points me to the row that I want to go to. And that's a nice mental model. Now, secondary indexes basically don't go out and rearrange the table. Basically, a secondary index points to the primary key. By the way, if you have long primary keys, you have long secondary keys, and it's more advantageous to have a shorter primary key. So let's create a table with a primary key. Here we're going to creating a table called T1. First column, C1 is an integer, not null. We'll talk about null later. Auto increment, that means for every time we insert a record, automatically this value will be incremented. Usually this is a value of 1, but you can set that. And we're going to designate this as our primary key. And then we have 2 other columns in the table. Now, an index is a list of keys. And you'll hear key and index used interchangeably. Also, we interchangeably use schema and database in the MySQL world, just common parlance for us. Now, the primary key is a key for the index that is uniquely defined for a row. Let me repeat that. Make it unique for the row. Make it immutable. You don't want to go back and change it later. Now, InnoDB works best if you have a primary key. If you don't designate one, it will make one up, and it may not be exactly what you want or need. I recommend not using null values, and you also want it monotonically increasing. That means adding every time I add a record, it increases the ID increases by 1 or some other set parameters you say. UUIDs do not increase monotonically, so therefore they're a bad idea for primary keys. If you need to use a UUID, store that in another column and then use UUID to bin for the value of your primary key. Also, you can index on the prefix of a column. Let's say you're in a country where last names are very long and you just want to be, and you've done some statistical analysis and you just want to index the first 10 of the name. That you've done some stats and figure out, well, that will identify 90% of your folks almost uniquely. Now, you can also have multi-column indexes. Here's a table calling test. We have a column, an integer called ID, that, by the way, is going to be our primary key. We also have a last name and a first name column, set of columns. Now, the index we're creating here, index name, last name, first name, will work when you're searching for last name, first name, or last name. It will not work on just searching for first name. The first one in your index, make that the highest cardinality, the most unique. That's the way it works. By the way, if you're doing something like month, day, year, the search will work on month, day, year, month, day. It won't work on year, won't work on month. Sometimes you have values that just don't really work well for an index. What you can do is create a hash. In this example, we're taking 2 values, we're concatenating them together and making a hash of that. Of course, there's other types of indexes out there. You've heard me talking about unique indexes, but we have full text indexes for those doing textual searches. Covering indexes, which means your index basically covers all the information you want for your query. No need to actually dive in the data. Secondary indexes, I'll harp on that again in just a minute. Spatial indexes for geographical information. Now remember, the secondary index is basically piggyback on the primary. And if the primary key is long, the secondary indexes use more space. So if keep the keys as short as you can, and be conscious that they do chew up memory. We also have functional indexes where you can do some sort of manipulation on value. My favorite here is the second one, create index IDX1 on T1. That's the table T1. We're adding column 1 and column 2 together. Maybe this is the cost of goods sold and this is the shipping cost, so you get the product cost. There's all sorts of things you do. You can also add an index column times 40. Maybe that's your overhead on your cost of production. Also, we have multi-value indexes. Previously, before this, you could have one entry in a column, in an index for a column in a table. Well, with the birth of the JSON data type and JSON arrays, that wasn't working. So now you can have multiple entries in an index for one row and a column. Basically, you index the entire information. We have some special new functions like member of that help you identify these. Okay, big rule number 1. Always have a primary key on your InnoDB tables. I hate to keep harping on this, but I see all sorts of issues on a regular basis of people that, my database just doesn't perform. Well, show me what your tables look like. Well, where's your primary key? What if you look at explain for your thing, and what is it doing trying to find the information? So please do that. As I mentioned earlier, InnoDB will pick an index if you do not, and it will not be what you need. By the way, if you want to find InnoDB tables without indexes, this is a handy query that you can run. Please pull this off the slides. What if you want to add an index but can't change the code? So like you have some legacy piece of code, and if you add another column in there, your select asterisk will come back and your code won't understand what's this new column named K. Well, we have invisible columns. You'll see invisible indexes in a minute or so. So alter table T1, add column K. It's an integer. We're going to make it invisible. And in this case, we're going to make it our primary key. If you do a select star from T1, you won't see K. If you do select star comma K from T1, you will see K. Once again, MySQL has two types of index structures, mainly. B trees, which is a binary search. This is for the most popular one you'll see. Also, we have hashes, where you basically put everything together and sift through that. Now, some of the heuristics you got to keep in the back of your mind is MySQL wants to use an index that has the smallest numbers of rows. It figures smaller number of rows, the higher the cardinality, it's more selective. Aha, that has to be the one I pick. Not always true. Also, MySQL uses indexes on columns more efficiently if they are declared the same type and size. Varchar and car is pretty much the same if they're the same size, so varchar 10 and car 10 are treated the same. Varchar 10 and car 15 are not, so things would have to be padded and shifted and cast and all sorts of other stuff. Okay, null. Null is one of those things that when you start playing with databases, if you haven't run into it before, is very confusing. Back in the early days of computers, they would designate something as false with a binary digit, 0 for false, 1 for true. And people started saying, well, what if we don't know what the value should be, whether it's true or false? We need something else to designate that. Because if we mark it as 0, it's going to be marked as false when we don't really know that it is true or false because we don't know. And we can't mark it as true because we don't know. So null came in, so you had this tri-state situation. Now, indexing null values really drives down the performance of indexes. Consider that you have all these lovely things indexed, and then you have kind of a junk drawer at the bottom with all the null values. Ignore those if you can. Now, sometimes you can create an index that covers just the right column so you don't have to do the dive in the index. That's called a covering index. This is an interesting example I want to show you. We're going to report on a salesperson activity by customer. In this case, we have a table that has orders from a customer. And what we want to do is we're going to select the customer ID, the total, the salesperson's ID from this orders table. And in this case, we're really interested in the case where the customer ID is number 101, the salesperson's ID is number 7, and the cost of the order is greater than 1.0. If we look at it with Visual Explain, we get told our query cost is 1.5. Now, if we index the customer ID and the sales ID, we can run the query again, and notice that it drops from 1.5 to 0.7. So 46% better. That's a big improvement. This might be, this example query may not run very often, but if this is the type of thing you run on a regular basis, it could be very valuable to save the time. Oh, by the way, some of you might argue that sales ID is probably going to be more selective and probably a smaller number than the number of customer IDs. Yeah, I make that argument. You can play with it and try with another argument. So let's index the customer ID, sales ID, and total. So we alter table, add index C3 on those 3 items, and we go down to 0.66. So we've gone from 0.7 to 0.66 by indexing all 3 columns in the query. Now it's only 6% over the previous, but overall it's 44% faster. Invisible indexes. Here's a picture of an invisible index. No, kidding, honestly. What happens with invisible indexes is, what used to happen before invisible indexes was you would be looking at an index from an explain and wondering, gee, is that index really helping me? You'd check your query using explain, and the index did not help you, so it's taking up space, let's get rid of it. So you remove that index, you start to rerun explain, and you start getting phone calls, text screams that everything's running slow. And then you realize that the index in question may have not had any utility for you, but it seems like everyone else on the planet needs that index, and you've got to go back and rebuild it. May not be a simple process. After invisible indexes, you doubt the usefulness of the index, you check it using explain, you make that index invisible. The optimizer for the entire system cannot see that index. You rerun explain, and you start getting the complaints, make the index visible, and then you have to worry about how do you blame it, network, JavaScript, GDPR, Slack Cloud, just something. But for a short time, that index was unavailable. By the way, the sysscheme will show you which indexes have not been used and are candidates for removal. Don't just blow it away because sysscheme says this hasn't been used. It might be a rarely used index that maybe runs at end of month or in a quarter. Be careful of blowing it away. Might just want to make it invisible. So how do you make an index invisible? Alter table, table name, alter index, index name, invisible. And to turn it back the other way, just make it visible. For those who use MySQL Workbench, one of the things you can do is run the performance report to see unused indexes, and it will tell you why they're there. Once again, make sure it's long after a reboot before you start picking out indexes to potentially blow away. Also, unused indexes take up memory, and they're also a maintenance overhead issue. So what you can do is run this query to go out and find unused indexes. Also, you might have tables that need an index but don't have one. In MySQL Workbench, you can go out and run a search for the statistics on tables with full table scans. That means the entire table is being read. Now, sometimes this is happening because you're doing quarterly end of month and you have to go through all the customer records to see who did what and to whom. If it's something that's popping up on a regular basis, check in to find out who's using that table and maybe add an index. Okay, histograms. Histograms are an interesting thing that was introduced with MySQL 8.0. Here's a list of the heights of 10,000 US females put into a bar chart by their height in centimeters. So Wikipedia says a histogram is an accurate representation of the distribution of numerical data. Now, histograms help the optimizer find the most efficient query plan. Well, how does it do that? Well, I'll show you in just a second. Now, we have 2 types of histograms. Singleton, where everything is in that bucket, logical bucket, where everything's divided, it has the same value or same range of values. Also, equiheight. You're going to have 10 buckets, and you're going to put 10% of all your data into each of the buckets. The maximum number of buckets you have is 1,024. Now, histograms are useful usually for data you cannot index or don't want to index. Now, a histogram is created and or updated only when you decide to do so. There's no regular process that runs that, although you could automate it if you want with a cron script or an event. So when you do that, there's no continuing overhead when the data is modified. Now, as the data gets changed, it kind of gets out of date. So if your data is really churning and burning, might not be a good choice for a histogram. So why use a histogram over an index? Well, every insert, update, and delete on an index key is maintenance. It has to be put into the index mini table and kept there. If it changes, it has to be changed. If it gets deleted, that needs to be noted. This can be a lot of overhead. If you have a lot of what I call competing indexes, where you have 4 or 5 indexes on the same column, that multiplies the task by 4 or 5. Also, occasionally the optimizer will take index dives to estimate the number of records in a given range. It knows something's kind of funky with the statistics, and it wants to go out there and update them. Now, since that happens on indexes and histograms aren't an index, histograms might be better and cheaper in case if you have data it doesn't really churn, like some piece of data comes in once a month or once a quarter. Now, the optimizer itself takes a look at your query after the syntax checker and wants to give you the most efficient way to get the data. And the optimizer is assuming that the data is evenly distributed in a column. Evenly distributed is not something that happens naturally for a lot of data. So histograms are great for giving the optimizer better data. Now, as I mentioned earlier, we have 2 types, equiheight and singleton. And I got a great example here for you. Let's do a frequency histogram. Each distinct value has its own bucket. Values are 101, 102, and 104. I have no idea what happened to bucket number 103. So we're going to insert into a table 2 values of 2 rows of 101, 3 of 102, and 1 of 104. And if we select our ID and the value from frequency histogram, you see that we have our 2 101s, our 3 102s, and our 1 104. Now we create the histogram with 3 buckets. And if we go out and take a look at the information, this is the way the system is keeping the data about the histogram. It knows that it's a singleton. It knows it has 3 buckets. It knows when it was updated. And if you take a look at the various buckets themselves, we have a bucket for 101. We have a bucket for 102. We have a bucket for 104. Now, for 101, the optimizer knows that 1/3 of the values in the table are value 101 and below. It also knows for 102 that 83% of all the values are value 102 or below. And for 104, it knows that all the values are 104 or below. Here's a nice little graph of what we see in the cumulative frequency and the frequency. Now, how do you create a histogram? Well, you run analyze table and you tell it to update a histogram. In this case, we're creating 3 histograms on column 1, column 2, and column 3, each with 10 buckets. If we want to update the histograms on column 1 and column 3, we can do that. We could change the number of buckets if we wanted to. And if we don't like the histogram on C2, we just drop histogram. Now, there are information on histograms available for you out there in the information schema. Borrow this query and it will give you information about what's going on. Now, here's an example where histograms shine. We're going to create a table, and it's going to have an automatic auto-increment ID. So every time we add in a record, it's going to increment by 1. We're going to have a column called X that's unassigned. So we're going to insert into our new table 2 1s, 3 2s, and 4 3s. If we select our values and the count of those values, you see we have the 2 1s, the 3 2s, and the 4 3s. Now, without a histogram, when we run a query like select everything from that table where the value of X is greater than 0, the optimizer doesn't know anything about that. Literally, I've just created the table, dumped in the data in there. It has not had a chance to go out there and build any statistics on this data. So the optimizer is going to make a wild ass guess, swag, and it's going to say, okay, I think that I'm going to have to read 33% of the 9 rows in the table. That's my estimate. If you ever worked with a building contractor or someone repairing your car on an unknown thing and they're going to give you their best estimate, you know how this is not as accurate as you would like it. So By the way, the filtered column indicates an estimated percentage of table rows that need to be filtered by the table condition. So the closer you get to 100, the better you're doing. So let's go out there and build a histogram. We're going to analyze our table histogram on column X with 3 buckets. Now we're going back, we run our query, we'll say, okay, select star from H1 where value X is greater than 0. And we know all our values, all our 9 rows have values greater than 0. And it knows that it's going to have to read all the rows, all of those 9 rows. By the way, if you run this explain analyze, it will come back and give you the actual time and the actual cost. Now, performance is just not indexes and histograms. There's a whole bunch of other stuff out there that can be done. Now, some of these tweaks are real simple to do. Other ones aren't. And to get through these, you're going to have to really start working on using the explain command. You're going to have to see if you're using file sorts. Maybe index, if you're doing an order by column, that needs to be indexed too so it goes faster. Sometimes you can't get away from full table scans, but maybe you can get away from a temporary table. Also, does the join order look right to you? Once you've been doing SQL for a while, you start getting hunches about how things should work. Sometimes your configurations need to be changed. Increase the size of buffers and caches. By the way, if you haven't heard this before, databases love memory. Maybe you're running out of memory. And sometimes your I/O just can't keep up with what you're doing. Now, I'm going to skip over the locking options and other stuff that came out there. These are really neat. These might change the way you architect your data. I do recommend coming back and reading these. Resource groups are handy. Optimizer hints. These are where you can actually tell the optimizer how to do stuff. In this example here, join order, you're going to do one column before the other, or one table before the other. So it can get around some of the optimizer's assumptions. Partitioning, multi-value indexes. I have some great examples here of using that. Some index extensions. So if you want to get better at this, what do? Well, first thing, install MySQL, get some test data, and start working with it. Be sure to read the MySQL manual. Great section. I believe it's chapter 8 on optimizations. It really is the guide on how to get things better. If you have specific questions, go out to forums.mysql.com. We have forums on the optimizer, on InnoDB, on database administration, just about anything you can think of out there. Our engineers watch these forums and they will answer questions on a fairly sharp basis. Now, if you go out to mysqlcommunityslack.com, they also hang out there and you get great answers. By the way, if you really get serious about this, I recommend the book in the middle of the page and then getting the second book. Jesper Wisborg Crow was one of our support engineers. He's gone off to another position, but he's a tremendous writer. He writes very, very well, very clear, very precise. These books are great value. His other books are also great value. He's a very, very knowledgeable person and can teach you a great deal about these. You really, really need these books, and they're available off Amazon. This is a book I'm reluctant to hesitate because it only goes back to up to version 5.5. A lot has changed. 8.0 was a major rewrite, and a lot of the stuff in here is now outdated and wrong. But a lot of the stuff about running explain is very, very good in here. I recommend going out and searching, use bookstores, make sure you get the 3rd edition. Supposedly there's a new edition in the works. I don't have any news on that, but I've heard that rumor. If you are working with the JSON data type, please go out and get a copy of my book, MySQL and JSON, a Practical Programming Guide. The manual is pretty good. However, there's not a lot of program examples or best practices. Version 1 sold very well, but we added a whole bunch of stuff between, so I've doubled the length of the book. And also covers how to use the NoSQL document store. So if you want to use MySQL as a NoSQL JSON document store, this is a big aid to you. Also, if you work for a startup, Oracle wants to help you. Oracle.com/startup. I get a whole bunch of credits, a lot of exposure, and some help and promotion. And with that, I want to thank you. I hope you have a great LA DataCon. Go out to slideshare.net/Dave Stokes. Look for LA DataCon, MySQL indexes and histograms to get a copy of the slides. You need to get hold of me on Twitter. I'm at Stoker. You can see here my blog. Also, there is planetmysql.com. This is the MySQL blog aggregation site. If you have questions, go out to forums.mysql.com, and of course, we have our Slack community. And with that, I want to thank you and have a great day.